This conference will now be recorded.
Hello, good morning, everyone. Okay, so in the last class we have seen some DDL and DML skills queries and their usage. Okay, so we have seen in creating table and altering table structure by inserting more columns or dropping the existing columns and altering the column types. So these are all possible. Then we have seen how to retrieve the data from database using the select query, using and insert table data using insert command, and deleting or truncating. And also we have seen various um, appendix of the select command. That means where condition and group by, and one more is order by. Order by we haven't seen, right? Okay, so order by we will see today. Let's.
You need the screen sharing?
Oh, wait. Yeah, order by till order by we have seen, so no issue. Okay, we have seen order by, right, on the last class, haven't we? Okay, so that's okay. There is one more left for the DML. It's
In the
not a
having clause?
actual. Not yet. I'll tell you.
Okay.
Okay, so that is like how to duplicate existing table. So in case you want to work on same table but without affecting its data or structure, but you still want to use it, so you can make a copy of it and call it some other name and you can use it. So that's for duplicating. Duplicator. So that's simple select star into table copy from table original. Okay, so this will simply copy all the contents of table original to table copy. So example would be select star into what is the table we have created? Let's say EMP
Class
on
and student.
student one from student. So this will create a replica of student called student one, and we can also create a replica based on a condition. So this will be syntax. So if I want to only copy those records or rows from student which satisfy a certain condition, then I can specify where condition. So it is similar to the where condition we use in select. So if I want to create a student 2 table from student where if I give a like a false condition, okay, so okay, so I forgot to tell you this. So this copy is structure plus data. Okay, so structure in the sense what are the columns and data types, everything will be copied as it is, including the data, that means record. So this will be the syntax. So syntax for copy structure only. Okay, that means no data will be copied, so you can insert more data later. So the syntax would be simply you give a false condition, that's all. So no need to wait some. Okay, go back. Select star into table, copy from table original, where false condition, any false condition. Okay, so that is a syntax. And let's put this here. Okay, so any false condition like 1 equals 2 will suffice. So this will not copy the data, but will only copy the structure, the whatever number of columns it has, whatever the type of columns it has, it will simply copy those. So okay, so we will see all the practicals later at one time. Select star into students. For example, if you want to, this is only for duplicating, making a copy of table, but within the same database. So for example, your database is like DB1, right? Within the same database. So you are in the existing database. For example, you created a database called Oracle or DB1. So this command and this command will only create the replica of the table within the same database, whatever database we are currently in. But if you want to duplicate or making a copy of table into from one database to another database, so it's possible that you have more than one databases, right? So let's write a syntax first. So select star into table copy from table original, but you mention simply the database name dot table original, right? Or if your name is a little bit elaborated, it's still hungry, and you have to mention the fully qualified name. So for example, sometimes you have to mention the whole name, like db1 dot your company name dot dbo dot then student, so it will be lengthy. So or server dot db dot your owner name dot the object dot, then comes the table name. So it can be lengthy. So database name may not be the only fully qualified name. So some just imagine a file which exists in a folder, right? So whole folder structure like C and your name, users dot your name dot documents dot then file name comes. So likewise you have to mention the fully qualified name. So it could be like this also. So database fully qualified database name. Right. So example would be same thing. You can copy this. Student 1 from students. So you just mention the whole thing like server dot db dot owner dot object dot then student. So that's a fully qualified name, or you can simply have the database name. So whichever is, so all you have to do is just you have to get the details of database, the new database from the DB. Okay, so this is mainly about the DML, especially the data retrieval, which is more important in the manual testing. And you don't need to duplicate the table unless you are required to. So don't worry. So whatever is discussed before, that would be sufficient. But we will see more just for the sake of knowledge. And jump to practical. I don't know why it is hung. Can I type? To 44 MB. Okay. Did I open anything? Yes. Okay. So another is constraints. So everybody knows about constraints, right? So check constraints to check whether the particular column should have been populated. That means it should not be left null and should be unique, so and so foreign keys and other keys. So domain integrity constraints. So that is called check constraint, and that's the first type. And then comes entity integrity check constraints. So there are like unique key, primary key. Okay, so these two come under integrity, entity integrity constraints. And the last one is referential integrity constraint. So everybody knows what is left: primary key, then foreign key. So that would be foreign key. So what is a constraint? How do you define a constraint? Anyone? Constraint is nothing but a restriction in English dictionary, right? And this can be applied on a column or a table in a database. So that's all constraint is in terms of a database. Restriction that can be applied on a column of a table. So just like putting a condition in terms of Java, you put a condition: if this happens, then that happens. So it's like cause and effect. So in here you just put a restriction, so limitation or condition. So we will see examples, and these will be used to establish the data integrity among the database tables. And data integrity is the process of maintaining correctness of the data among the database tables. So based upon the type or restriction, we are applying constraints and categorizing into certain ways. So domain integrity is one of which. Domain integrity is one of those ways, and the domain integrity constraint can be applied on a column of a table with a condition, and only these values which satisfies this condition will be allowed into the column. So if you try to enter any other uh, data which does not satisfy the condition specified, then it will not allow, it will throw the error, like we have seen the other day. I mean, that error is pertaining to the using the keywords. Of course, class is a keyword, blah, blah, blah. But so if you put, if DBA has put some condition on certain column, then you have to add to the condition. So you can check the conditions and data types and everything in the database by exploring the database before executing the SQL query. So, and entity integrity constraint is it's the same thing as domain integrity constraint, but this entity integrity constraint can be applied on the table I mean column of a table, and once we apply this constraint to the column, that column will not allow duplicates. It has to be unique, and within this constraint value we can identify different records and other data of the columns. So these two will take care of the uniqueness of the column of any table. And referential integrity is just to establish the relation between these tables. So that's why it is called referential, and it defines that data to be entered in a column must have matching value in another column in another table. So always primary key and foreign key go hand in hand. So it is just to have the matching value in another column of another table. So that's foreign key. So let's start seeing the syntaxes and examples of each of these constraints so that you understand. So first, check constraint. Okay, so what is a check constraint? Again, tell me. I just not told you. What is it used for? Anyone jump? It is used to provide condition to the column of the table. While entering or modifying data of the column, this constraint will be activated, and it allows only those values which satisfy the condition. Okay, so example or syntax would be, for example, DB has already said like create table name, and I can take example of create table itself. So here you mentioned column name, so it has to be column name 1, and use specify data type and its size. Okay, so that's the first column. No problem. This doesn't use any check constraint or something. So this would be like regular column. And now we will use constraint on this. So it's optional. Okay, what I'll do is I'll use the constraint in the same line so that you know that it applies to the column one. So constraint you mention or don't mention doesn't matter. So hence it is optional. So you mention the word constraint, that is a keyword constraint, and followed by space, then constraint name. You can give any name, and constraint type. Constraint type in this case is check constraint. So check is a keyword, and you simply put the condition. Okay, so then follows the column name blah blah blah. So rest of the thing, column name 2. Okay. And this continues. Close the bracket. So that is the syntax. So examples would be create table department and department number integer, department name char 10 or varchar 20, department size integer, and I want to put a constraint on department size. So I'll mention constraint, and it's better to use the name explicitly, what is the constraint type and what column what table you are applying and what column you are applying, so that it is for readability purposes and usability purposes it is very clear. So this constraint type I'm using is for check constraint, right? CK in short, and the table I am using it on is department, and the column I am using it on is D size. So now it is clear. With just by looking at it, I would tell it's a check constraint which is on the D size column of department table. Okay, and then you put the check keyword, that's a constraint name, and check keyword and the actual condition. So I want department size to be greater than 20. So that's my condition. That means the department should have more than 20 people in it. Okay. So, okay, let's see. This is what the DBA has given. Now I am trying to insert. Okay, the table is already created. Now it's a time of insertion. So insert into depth values. There are 3 columns, right? Department number is 10 and department name is HR within single quotes, and department size is 30. Okay, now will it be successful if I run this command, or will it throw error based on the constraint? Tell me. Anyone? Check against the constraint. Is it satisfying this condition? Okay, so this is the condition, right? And this is the value I gave while inserting. This is the condition the DBA has put while creating a table. Now, is this value satisfying this condition or not? Yes or no? Tell me.
It's not satisfied. It's more than 20.
So that's good, right? More than 20 is satisfied.
No. Oh, yeah, satisfied.
Again, take a look at again and tell me. Is it satisfying? It's simple maths. Compare.
It's satisfied. Satisfied.
It is satisfied, so no error. Okay. So that's a successful scenario, right? So this is going to be success. Okay, I'll write one more insert. Department name, department number, and department name admin, and 15. Okay, so how about this insert query? Is it going to be successful or failure? Now
This
this
one is not successful because
successful,
no, not successful.
not successful. Yeah. Okay. So it will throw an error simply.
Mhm.
Error why? Error since the D size value is not satisfying the condition. Okay. Now we have the developer DB. Actually, developer is for Java or whatever code language it is, and DB has set this condition. Now he can also remove or modify this condition, the constraint check condition. So that deleting a check constraint. Syntax is just using the how do we delete or modify or drop, add more columns to a table using alter command, right? So using the same alter table name, then I want to drop not the column but constraint, right? And then constraint name that will drop. So example would be alter table department drop constraint name is, I don't have to think again even without looking at it. I would say because the naming convention is following the standards, then I can say it's on department. Hey, the constraint name is the check constraint and it's on department table of department size column. So this will remove. So after removing this, even if I run this insert command, it would not throw error. It will be successful. Okay, so just to give you a heads up, what are the different notations of constraint names? Okay, we will see the later the remaining constraints like entity integrity and referential integrity, which are like unique, primary, foreign. But just to mention, how do you give the names of the constraints? CK underscore depth underscore desize. Okay, I will mention the others naming conventions so that we can be I mean we can, without having to look into it, we can just, it acts as a heads up. Constraint, check constraint, CK stands for it, and table name underscore column name. So this is the like syntax of the check constraint name, not the check constraint itself, or nomenclature. Unique constraint. So UK stands for unique, and then rest of the thing is same because you apply constraint on a column name of a certain table. Okay, how do you erase this? It is all drawing, so perfect. Okay, so then comes primary key. Primary key constraint, you can use PK, and table name, column name, same thing. And then foreign key. Foreign key can be used, can be denoted by FK, table name and column name. So these are the notations. So I just putting them as a note. Okay, now I have created, I'll actually move this notation section before, because check constraint. Okay, so this is right place. Okay, so creating table, at the time of creating table, the DBA can mention the constraint name, and after I as a DBA have mentioned the constraint name at the time of creation table, then I want to drop it, then I can drop it too. And let's say I want to add more constraints after creating table too, because it's entirely possible. Now how do I add check constraint? So these are all after the table has been created. So if the table is already having any data, then the condition to be added must satisfy the existing column data also, otherwise it will throw error. Okay, so if the columns like d size, okay, for example, already there are d size like 20, 30 and 15, and I am adding this condition again, okay, so that would not satisfy this condition already, right? So it would throw error. So if you are putting a condition, adding a check constraint, if the table has any data, if at all, then all you have to make sure is the existing table data of that particular column is already satisfying the condition you are going to give. Okay, so that's the first and foremost thing. Otherwise it will result in a conflict. So syntax would be alter table name, add constraint, and constraint name, then check, and then condition. Examples would be insert into department values. I want to insert 20 admin, right? Now let's say okay, so before that we have to insert example for adding a constraint. So I would use same thing, but I will just, instead of drop, add constraint name, then check, and condition I'm putting is, condition is let's add okay, so condition, let's put same thing but a little bit different. D size greater than 15 is the one last time put. D size, okay, let me put greater than or equal to 15. Okay, so that means I'm adding a new check condition. So the examples followed by, so then as a DB or as other database team member, I am putting this as a 15. Okay, so now tell me, is it going to be successfully executed or not? Yes. So the new condition I put is this, and the data I am trying to insert into database table is this. So is it satisfying or not?
Sure.
Success. Okay, so I'll take one more example. How about this? Is it going to be successful or failure?
Going to be failure.
Failure or successful?
Failure.
Fail? Why?
Actually successful.
Oh no, it's successful.
Just check the condition. That's why I highlighted clearly. 60 is greater than or equal to 15. True. So it's success. Okay, so now let's take one more. I am trying to insert another table. Record 40 HR. Okay. Okay, how about this?
Fail, error.
Fail, error. Okay, so all you have to just make sure is whether the table row data you are trying to insert into is satisfying the condition that the DB has put on or not. Okay, so that's about adding a condition by altering the table. So okay, so now I am going to use update. Okay, instead of inserting, I am using update command. Okay, so now you tell me whether it's going to be successful or not, right? I can also update, correct? So instead of inserting, I'm updating. So let me update department by setting d size equals 25, where d size, I just want to change the department size is less than 20. Okay, so I'm just trying to modify. Okay, so this will modify the records who have department size value as 20, and all those will be 25. Less than 20 will be made as 25. Okay, now will it be successful or not? It will be successful, right? So it will basically do not update anything because already condition is greater than 15. This would throw error, and there are no d sizes which are less than 20. Or there are, oh sorry, there are 15. I put 15, right? So now it will try to update the 15. The 11 will not be executing at all. So forget about this. So 15 will be updated as 25. So this will be successful. So another example would be, if I want to update d size to, let's say 0.5, where I want to dename, I want to update all those department sizes which have admin name as department name as admin. Okay, so now is it going to be successful or not? So
No, because our department name only for 20, 30, and 40. You put only for 05.
Oh, no. Department size I am talking about.
Oh.
Department size is...
No, this one is error also because
because it will go for the admin and
Yeah.
check 15, and it will try to update d size to 0.5, and check condition is it must be greater than or equal to 15. So suddenly it will throw error. It will basically check against the condition always. So this is going to throw an error. Why error you already know. Okay. No, that's enough about the check constraint. Then we will move to the unique constraint, which is a part of entity integrity constraint. So unique constraint is just to avoid the duplicate. That's all. Okay. So what is a unique constraint?
Unique constraint accept the null value, but a duplicate is not accepted.
Correct. A column with unique constraint will not allow duplicate values, but allows a null value. Okay, so it's not a not null check. Okay, so just to avoid the confusion I'm mentioning, unique constraint will not allow the duplicate values. Okay, so if I mention like if this, okay, we'll see more, but I'm just telling you, if I have 20, I mean department number is constrained with the uniqueness, then if I try to insert 20 here again, then that would be duplicate, so it will throw an error in this case. Okay, so this is okay. But if I do not enter anything, right? Okay, so like null, it is still allowed because I did not put the null condition, not null condition. So let's see. So a table can contain any number of unique constraints. So it's not that it has to contain only one unique constraint. And in case of Oracle database, unique allows any number of null values. Whereas in case of SQL Server database, unique allows only one null value. That is a difference. So you just make a note of it. And creating a unique constraint syntax would be, I'll just copy the whole create syntax so that I don't repeat. All I have to change is the constraint name and type. Okay, create table name, column 1, data type, size, constraint name, and instead of check, it will be unique. Okay, and rest of the story goes blah blah blah, column 2, and so only the difference is unique doesn't have a condition, it just has unique. Already condition is mentioned, so I don't have to mention the condition, unlike I mentioned the condition in the check constraint. Okay, so examples would be create table, employee, and employee ID integer. Okay, I'm putting, always remember the unique constraint has to be on the ID, so that's standard. Because ID, for example, if you have any ID, student ID or any ID, you cannot have the same ID for more than one person, right? So otherwise it would be causing confusion. So it's a common sense thing. So I am putting the unique constraint on the employee ID. So it's very, whatever the first column, ID, so it's always unique. It should be unique. So it's 99% of the time it is true, but 1% of time it may not be. So that's why it's not a general statement. Okay. Employee ID integer constraint, and constraint name, like I mentioned, according to naming convention, it has to be UK underscore EMP underscore EMP ID, and the type of constraint is unique. Okay, that's all. Then rest of the ename, char 10, okay, those follow. So this will be successful, no issue with this. And if I try to insert into EMP values 100 and EMP name is Shukla, let's say. Okay, is it going to be successful? Okay, so I created a table, done, with the constraint, done. Now I am trying to insert into, now this is where you have to look out for the success or failure. So is it going to be successful? So first time I'm inserting a table row, right? So it's always going to be successful because there is nothing to check this employee ID against, right? 100 is first time, it's already 100. So
And this
this,
one is successful.
yeah. So that is successful. First time there are no records in the table EMP, and I'm inserting for the first time 100. So no issue. Okay. So next is Russell. I'm trying to insert this. Okay. Now tell me, is it going to be
This one is
successful?
error.
Error. Why?
Because
Why?
your
Because
ID number is same, that's why.
correct. Yeah. So I already put unique constraint on the employee ID. Employee ID is the first column, and the value 100 is already been used. So it will check, okay, hey, 100 is there or not? Yes, already there. Throw the error. So duplicate values in the EMP ID column are not allowed according to the constraint that developer or DB has set. Okay, one more insert into EMP. And this time I want to only, I have an option, right? I can insert all the columns data, or I can insert only chosen columns. Okay, I want to only insert into ename. Okay, so I just have to mention the column name in the brackets, values, and in that case I don't have to mention anything about the EMP ID. So EMP name would be Sang. Okay, so now tell me, is it going to be successfully
This
executed?
one is success.
Success, because I did not mention anything about the null value. So here simply the record will not have any value for the first column EMP ID, but it will have EMP name as Sangam. So since it's a unique constraint, it's not a not null constraint. So there is no issue. Not nullness is not checked. So nullness is allowed here. Okay. So one last example for this category, insert into EMP. Okay, now I mention name only, EMP name values. Okay, now let's put who else? Moz. Okay, now tell me, is it going to be successful or not? So I am inserting ename Moz, right?
This one also success because different name.
Sure. Think again. Otherwise I wouldn't have put this example
Name. Hello.
again.
Yeah, I think because the name is not same.
Name is the same, but is it satisfying the unique condition, unique constraint here? Constraint is unique. What is the unique constraint on EMP ID, right? That means it has to be unique. Okay.
Yeah.
Now, what is my EMP ID in this case? What is the EMP ID here? It is
EMP ID is 100. You go to the 100,
no,
but
it is null. I am not passing the EMP ID, right? Inserting
yeah,
just
you passing only for name.
right. So that means EMP ID is null, right?
Yeah, ID is null.
Okay,
But
so null is allowed because it's a unique constraint. I am not checking the nullness, so it's null is allowed. But in the previous record, I already inserted null. This is also having null, right? Null and null both are not unique, so this null is not allowed here. Is it?
yeah, that time this condition is, yeah, this one is error. Yeah, that time.
This one is going to throw an error. Okay, so we can add unique constraint also, just like we altered a table by adding a check constraint, altering. So we can also have those. Oh, so basically alter in the sense add constraint, unique constraint. So syntax would be similar, so I don't have to retype it. Drop, okay, where did I add? Adding a check constraint, so that would be syntax. Alter table, table name, add constraint, constraint name, instead of check, it would be unique. And okay, what is this uniqueness on? I have to mention, right? So that is column name. Okay. Now examples would be alter table emp add constraint uk underscore emp underscore emp id. So if already it's not mentioned, I can add it like this, unique and on emp id. So that would be how you are going to add. So actually, okay, because we have already added, it doesn't make any sense why we are adding duplicate unique constraint. That's silly. So let's firstly delete it instead of adding. So alter, delete or drop. Okay, unique constraint. So I'll just mention constraint in short const. Okay, instead of typing it. So the condition syntax would be the constraint. Where did we delete? Yeah, so drop. Oh, not here. Syntax alter table drop constraint, constraint name. So I already dropped it by mentioning the constraint name. It was already there, uk underscore emp. Now I'm trying to add it. Now it makes more sense. Alter table example will be constraint uk. So this will be added. So there's nothing new about it. It's just how do you drop it and how do you add it. Okay, now let's check the primary key. So primary keys, it's a column with this constraint will not allow duplicate values and not null values. So basically it's a combination of not null check and uniqueness check. Unique constraint only checks about the unique values, right? So the primary key, whatever this primary key is defined on any column, it will not allow null values too. Okay, so that's an additional constraint. So that's the only difference. Column with this constraint will not allow duplicate values and null values. Okay, so it's basically a combination of unique and not null options. Okay, so the primary key can be given only once in a table. This can be allocated to a column by using which we can identify different records and other data of the table. So how do we create a table constraint primary key on a table? But at the time of creating it, syntax of creating table with this constraint would look like this. Table name, column 1, data type, size, fine, constraint, constraint name. Instead of unique, I'll just mention primary key. That's all. And rest of the story is same. And we will create department table and then mention this constraint. Then we can try to insert and see which is satisfying, which is not. So department number, integer, constraint, I'm putting it on primary key. So pk stands for primary key, and department table is the one I am using it, and which column I am using it on, department number, and the type of constraint is primary key. Primary and key both are different words, so dname is another column, no constraint, so I don't mention it, and dsize, no constraint. Okay, so we can have as many not primary key, but you can have other constraints on different side, like dsize. You can combine the other constraint with this one. Okay, so now I'm trying to insert into department values, let's say 10, HR, and 30. Okay, so is it going to be successful or not?
Yes.
Okay, imagine first time I'm inserting, I'm using the same record. So just imagine this for the first time, right? Not the earlier also we use. So the table created freshly just now, and I'm trying to insert this record. So first time, no problem, right? So the primary key is on department number 10. It has to be unique and not null. Here first time unique, there is nothing to check it against, and it's unique and it is not null, and this is success. Okay, so same, I'll repeat with the different data values. So okay, department size, let's say 40. Okay, now you tell me, is it going to be successful?
No error because same ID.
Correct. So 10, 10. So according to the primary key definition, combination of it's a unique, does not allow duplicate values. So it will throw error. Couple more examples. Okay, so this time what I'll do is, instead of all of them, I'll only insert into few of them. Department name, in that case I have to explicitly mention. If I don't mention anything, that means I'm going to insert into all columns. That's mandatory. If I do not want to like insert into some columns, then I have to mention what columns I am going to insert data into, so explicitly. So that is mandatory. Okay, so I'm going to insert into dname, department sign, department name, and department size, avoiding department number. So values will be, of course, let's say testing department, and that's department size is, let's say 20. Okay, now okay, how about this? Is it going to be a fail or pass?
This one is pass.
Are you sure?
Okay, wait. This is name and then department number.
So this is the raw data, I mean record, and I put this constraint.
Yeah, this one is fail because we need the department number also.
Right.
So we put the primary key for the restriction for the primary key and then department number.
Right.
We must need, that's the error. This one is error because we don't put the department number.
Yes. Why? Yeah, you're right. Your reasoning is right, because null values are not allowed. I mean, it has to be not null, in other words. Okay. And I'm inserting null value here. Implicit, not explicit.
Null is not accepted.
Correct. Null is not accepted. So this is going to throw error. Okay, one last example. To erase. Okay. Okay, so department size, department name. So okay, just think carefully and tell me. Don't jump to it. Okay. Okay. How about this?
This one also error because we need only for number. 0 is not accepted.
Right. 0 is a number. 0 is an integer, right?
Yeah, I integer, but
So what is the problem? It is an integer. 0 is an integer.
I know
Department.
this one is integer. Yeah.
Yeah. Integer is what is
0,
the
0, 1 or 0, 0, 2. You put it that time, maybe data is accepted. Totally 0, 0.
not realistic, but I just wanted to test. Okay, 0, 1. Let's put 0.
Yeah, this one is accepted.
Right. Okay. Anyway, this is false. Okay, so that's about the primary key. So far we have learned about how many constraints. Unique constraint first is check constraint condition, and then unique constraint, then unique with not null constraint, which is also known as primary key, right? Okay, now what is the difference between unique constraint and primary key? Okay, that's an interview question. What would be your answer? Standard interview question. What is the difference between
Unique
unique?
concept is accept for the null value, not a duplicate value, and then primary key don't accept the null value.
Right. Yep. And okay, anyone else? Any other difference? That is the one difference. There is one more difference. A table can have any number of unique constraints, but a table can have only one primary key, right? So if I put a primary key on first column, let's say department number, okay, I cannot use the primary key on any other
Sangam.
column. Yeah.
At the different field also I put the primary key, not only for department ID. That time is restricted. Okay, you put the primary key also. What is the field name? D name and D size also you put the primary key. That time this one also must need for the data, and then we didn't put the empty data.
Oh, no. You are mistaken. Okay, that's why I'm trying. That is the difference. Okay, let's have the differences. Differences between unique and primary key. Okay, now let me list it out. I thought you understood, but let's just avoid them. Okay, first difference is correct. You told correct. What is the first difference? Unique allows null values. Okay, whereas primary key, let's say PK, does not allow, right? Null values are not allowed in primary key. So we just saw this. If I insert null value, it's going to throw error. But in unique key, it is allowed. We have already seen. Yeah, if I enter this one, null value, it is success, right? Okay. Now, second difference is a table can have any number of unique constraints. But it must contain only one primary key. Okay. In other words, I can put unique constraint on department number, department name, department size, no problem. They have to be unique. So simply I'm saying it doesn't make any sense, but simply I'm saying department number has to be unique, and okay, department name has to be unique too, which is not a realistic thing. So because there are many departments in a project or any company, and department size also varies. So it's simply because it's not realistic, I'm not putting it on. Otherwise, it's allowed. Uniqueness is allowed on each I can put, but primary key is not allowed except for one. Okay, so if I use primary key and department size, let's say, I cannot.
Okay, without unique constraint, I didn't use the multiple primary key.
You should not use a multiple primary key in a table. That's what it says. You should not. Okay, so you're trying to put, let's say, department number integer, constraint, PK, department number, primary key, right? Now I want to put department number or department name. Okay, constraint. Okay, unique. Okay, this is allowed, but constraint pk underscore department number underscore d name.
Not null. Yeah, only primary key and then other field is
It
not
is
null.
not allowed because
Yeah.
I cannot use multiple primary keys in a table. So only
Yeah.
one primary key.
And then not null I use that time. Okay.
Yeah, not null you can use. Primary key is a combination of not null and uniqueness. That is not allowed. So this is going to throw the error right away. So that's just okay, that difference. And one more difference is with the creation of primary key constraint, by default, a clustered index will be created on that column, whereas with the creation of unique constraint, by default, a non-clustered index will be allowed. So that's internal. So you don't have to worry about it. Okay, so you can try adding primary keys on existing table on your database Oracle. There is you created EMP table, right? So just try to create or add, okay, a primary key into that and see. So you know how to add, right? Shukla, alter.
Yes.
Alter table, yeah, this one, alter table name, add constraint name.
Constraint name, yeah.
Just put the primary key and blah blah blah. So
Yeah,
same thing.
And the depends on which one I like it. That time I'll use it.
Right. Okay, so that's for homework. And composite primary keys. Suppose if it is not possible to provide a primary key in a single column of the table, then check the table data to identify some combinations of columns by using which we can identify different records. So if it is found, make that combination as a primary key. So that is called composite primary key. Combination of like 16 columns can be used in this type of primary key. So composite column is nothing but composite primary key is nothing but a primary key put on multiple columns at the same time. So this can only be used if it's not possible to provide PK on single column, then use combination columns to put this on, put PK on. So that is called composite primary key. So example wise, let's say you have orders table. Okay, the table name is orders, and it has columns like serial number, order number also. Okay, and order date, and like inventory number or something. Okay, blah blah blah. Now I want to have composite primary key on serial number and order number both. So this will be because serial number is unique and not null, and order number must also be like it has to be 100. Okay, so the date can be anything 12, 16. 11, let's say 24, 2018, and inventory number is, let's say, in 001. Okay, so then 200. Okay, so the order number cannot be 100, so then immediately it will throw error. So you must have the composite primary key here, so it has to be like 101 and blah blah blah. And the same thing for serial number 1 to 1. So this cannot be. So again you have to have check. So it has to be unique and not null also, right? So in real time, 4 column combinations can have unique composite constraint, composite primary key constraint. So for creation wise, syntax would be similar. Create table. Let's. Okay, instead of this, we'll let you, for example. Let's say I'm creating table called orders. So this will have serial number, integer, order, integer, order number, and order date, which is of type date time. Okay, so that will only take date time type of values. And let's say inventory number, which is combination of alphanumeric. So cat where cat 230. Okay, and on I am going to create a composite primary key and serial number and order number like. So what I would mention is constraint pk. It's a primary key only, even though it's composite. I just have to make a differentiation in the primary key output on which columns. That's all. pk order number. Okay. First one is serial number underscore order number. Okay, so two columns, then primary key and on serial number and order number. So that will indicate, okay, primary key is on both columns, composite. So it's not possible to add a primary key to an existing table, even though it's not having duplicate values or not null values. So to add the primary key, at first provide an option called not null to that column. So the examples would be create table on EMP, you can see, and then try to insert table table records and try to alter them by adding more and see if it throws error or if it does not throw error. So same examples you can try. All right, so I don't need to. That's for homework. Okay, now let's jump to the last and final constraint, foreign key. Okay, so what is a foreign key? Foreign key is, like I said, it's
reference key.
Integrity constraint, and this goes hand in hand with the primary key. So let's define it. So foreign key fk is used to establish a relation between tables. So the foreign key can be given to a column which is having the same data type, data and size as of the primary key column. Okay, that's when on a column which has same data type, data value and size as that of which one? Primary key column. So the table with primary key, foreign key, is called as referential or child table, and table with foreign key is known as referencing or child table, and the table with primary key is called the referenced or the parent table. Primary key is known as referenced or parent table. So let's see the example. and let's go to one. So once we establish a relationship between the tables, a lot of restrictions will be applied to the database operations. So those restrictions are the data to be entered into foreign key column must have a matching value in the primary key column of the parent table. Okay, so that is the first condition you need to check. So I am just putting these conditions or restrictions or limitations. So number one is matching value. Okay, so if you are entering data entered in foreign key column, whatever foreign key it has must have matching value. Okay, so you already created an employee table. Now that has a column, and if you're going to create another table called department that has a column which are both matching. So at the time of creating, you just make sure that and you put the foreign key in one of those tables, primary key in one of those tables, other table I mean. Okay, so matching values in primary key column of another table. So that is called parent table. And it's not possible to directly delete a record value if you are deleting from the parent table if it is having a reference in the child table. So if you are trying to delete such record, it will throw error, referential integrity error or something. So entering wise, you have to make sure the matching, and deleting time also, you just make sure. So it's not possible to directly delete a record from parent table if it has reference in child table. Okay, now how do you create a foreign key? Syntax. So in this case, I am assuming that EMP table is my child table. Okay, so you already created it, so syntax would remain same. So let me take create table name, column 1, data type, size, then I constraint, so constraint name, and instead of primary key I would mention references. References for parent table. And primary key column 1 or column, whichever column it is. And I have to, this is optional, so on delete cascade. Okay, so then rest of the columns too will continue to be created. So you can put another type of constraints here. Okay, so child table with foreign key may have null and duplicate values in primary key reference column. So now examples would be, okay, first we'll try to create, then try to insert and see if it is successful or not. So create table EMP with EMP ID, integer, ename, character, extend, salary, integer, and I'm also putting department number. Okay, that is a common column going to be in the department table, so watch carefully. So I'll take next line, department number, integer, constraint, and foreign key EMP table and department number it is on, and this references, okay, department tables department number column. Okay, so the department table has already been created, so that acts as a parent table and the EMP table is child table. Okay, now let's try to insert into EMP. I'll use 100 employee ID and employee name is let's Naeem. Okay, and the salary, right? Next salary is 50K, and the next one is department number. Okay, so department name is testing, that is in the department table, so don't worry about that. Okay. Okay, so now tell me, is it going to be successful or not? So imagine, I mean, remember this is the first time I'm inserting to, so it's fresh data. Okay, now okay, department table is already there, right? So department table has this data, let's say. Okay, so I'm just mentioning department number so that you can have other department name and department size, blah blah blah, right? So let's have department number, or have we created department table here? Okay, forget about it. So department number, let's say 20, and 10, 20, 30. Okay, so let's say only 3 records, and okay, how about this? Is it going to be successful or not? So just check, data entered in FK column must have matching value in a primary key column of the parent table. So in this case, parent table is department parent table. Okay, now is it satisfying the condition? FK column must have a matching value in PK. So I am trying to enter department number 20. So does it have a matching column?
Yeah.
Yes. So you can just have another record. So I'm just putting one, blah blah blah. Okay. So that is pause. Okay. So if I take inserting to 100, 200, so salary 70K and okay, so how about this? Is it going to be successful?
Error.
Why error?
Because we don't have any primary table. Balance table is no 50, only
Right.
14, 20,
So,
and 30.
yeah, matching column is not present in the parent table. Okay, so this is a fail. Okay, so you can create more examples like this, and also if I try to delete, because that's another condition, directly delete. So let's take one example, department where department number equals 20. Okay, now tell me, is it going to be successful or? Okay, so remember I have already executed these two and there is some data. So then I'm trying to delete. Now read the restrictions, inserting and deleting. So it's not possible to directly delete a record from parent table if it is not, if it has a reference in child table. So does this parent table has a reference in child table? I am trying to delete from parent table department number where department number is 20. So all these records, right? Now there is a department number 20, the record with or records with department number 20 in the child table called EMP. So this deletion is not allowed. Simple. So this is going to throw an error. So okay, and the on delete cascade is just to it's not possible to delete the records from the parent table if they are having a reference in the child table, and this is just optional on delete cascade. So the deleting condition is taken care by the on delete condition, but it differs from database to database. In Oracle, different convention, and SQL Server different condition. So this makes it possible to remove the parent table record and all its child table reference at the same time. You can use on delete cascade in the foreign key constraint, and you can have alter tables, EMP drop constraint. So FK underscore EMP underscore department number. So this will remove entire constraint. So removing or deleting constraint, foreign key constraint. And if I want to add it, I can simply alter table EMP add constraint FK underscore EMP underscore department number foreign key on department number references department tables department number on delete cascade. Okay, so you can play with this both tables. So you can just create one more table, department and EMP, one parent, one child, and you can play with it. So you have to remember that the maximum of 253 references can be provided in a single table. So that's for DBA. Okay, so that's about constraints. So okay, constraint is not very useful for the testing purpose, whether it be manual or automation testing, but it is good to know. So the important concept which is going to be helpful in manual testing while writing simple select queries and automation testing also are joins. Okay, so because you have not just one table in a database and you have to deal with multiple tables in order to fetch data, right? So it's important to use joins. What is a join? Join is a
Two or multiple table joining together.
right, yeah. So it's a simple select statement used to retrieve the data distributed among different tables. Join is a select statement used to fetch data from multiple tables. Okay, so in order to join the tables, we must have a common column between those tables, and common column means name of the column can be different, but the data type and size and the data must be the same. So based on that way, the tables are provided and the records, their joins are used, categorized into multiple join types. So anybody can specify the join. What are the different joins available? Inner join,
Inner join, left outer join, right outer join, full join.
inner join, outer join. Okay, again outer join is categorized into multiple. Let's see, outer join, then cross join and self join. Okay, so inner join, outer join is categorized into how many parts?
Part, right outer join, left outer join.
Left outer join, right outer join, and full outer join, both left and right. Okay, so simple syntax of a join would look like this. Select column list from left table, then you use join type keyword, and then right table. You can treat left table, right table according to your wish, so there's no restriction, but you just fix on those left table, which is the right table, on criteria. Okay, so that's a generic syntax. So inner join, let's see. So what is the inner join used for? It's used to get only the matching data between two tables based on the common column. Simple. So to get only matching data between two tables based on common column. Okay, so let's say we have a class table and student table. Okay, like last time we defined. Okay, why don't we directly do it on the SQL server? Because that way we can have two tables and we can apply joins. Or do you want me to first tell you the theory and then we'll jump to the practicals? It's up to you. Okay, so we'll just see the theoretical aspect, then we'll jump to the practical. Okay. So let's say we have two tables. Table 1 or left table, you can treat. My left table is class. Okay, oh sorry, class is a keyword, right? So let's use class 1. That's what we used last time. Okay, so okay, no, let instead of this we'll use student table as left table, and student table has student ID, student name, class ID, and marks. Let's use the pipe because in Notepad I cannot differentiate between columns. Okay, so these are the columns and the data I have is one. Student name is A, 101, marks 300. Two. 3, 4, defined, and student names A, B, C, D, E. Okay. This can have later. Okay, I'm just putting one null. And marks 200, 150. Okay, so this is the data. Let's say this is the left table and the right table is class 1. Okay, so this has columns class ID. Okay, so my common column is class ID. Class ID is in the student table and class ID is in the class table as well. So then class name and class size. Okay, so just to have, okay, let's not have anything else. Okay, so class ID is 100 and class name is testing. Class size is 25, let's say. Okay, so class ID is, let's say, 101. All right, 101 is referring to, let's say, Java class, and that has 10 members. And 102 is, let's say, automation. Automation, and it has, let's say, 12 members. And I'm just trying to create enough records to play with. 103, which is not there, so let's take one extra record which is not there, and this is database, and this has 5 members. Okay, so let's say this is the data in the class 1 table. Okay, now my intention is to retrieve the matching data between these two tables, student table and the class 1 table. Okay, so that's my SQL. Select SID, student name, then I can use aliases, so that I will use later. So I am creating aliases for, instead of mentioning student every time, student alias yes, and class 1 alias C. Okay, so SID, SName, and since there is an ambiguity between the CID column is present in both student table as well as the class 1 table, I have to explicitly mention which table this column belongs to. So s.cid, okay, and that S is a table alias, and I can give column alias for s.cid because it's not very readable, so I will mention student CID, okay, or class ID. That's explicit. and then c.cad from the class. So that is class ID itself, class ID. Okay. Then I'll mention cname from student table. Yes. Then inner join is a keyword, class C on the condition. If I don't mention the condition, basically it will retrieve all the records, but mention the condition will fetch me the matching records. C.cad or s.cad left table cad equals c.cad. Okay, so that's my inner join. Select column list. I can also mention star, but column list from table, left table, join type, right table. Inner join is a keyword, and on criteria condition. So you can say this is a syntactical and example wise this is complete. And what would be the output? Anyone? How would the output look like? I could have also mentioned simply select. Don't get confused with all the column names. So instead, I'll start with select star from students. Yes, student. Yes, class 1C, where s.cad equals c.cad. Okay, so this is same as the above one. Only I chosen the particular columns to display. Okay, so now what is the record that is going to display? So I just want you to tell. This is a student table, this is a class table. So look at them. What are the matching columns that are satisfying condition like both have same CID, class ID? So look and tell me. CID 101, right? 101 and CID 101 here. And CID 100, can I change the color? No, okay. So CID 100. Okay, let's start with 101. Okay, so or let's mention the 100. Okay, so this is the other column. I'm just underlining it. Okay, and 101 is there. So and 102 is here. Okay, 103 is not there and null is not there, so that's not count. Okay, now tell me what are the records that are going to display? Yes. Okay, so let me write down all the columns. Okay, according to first query, SID, student name, and the student class ID. And the class ID and CNAME, right? Okay, so tell me the matching records. What are the matching records? Student ID 101, right? 101 is there, right? So 101, what is the student ID? I mean CID
101.
1.
And then
SID is 1, right?
Yeah.
Right. And then student name for this is A. We will execute on your screen, your machine, don't worry. But before that, we'll do this. And what is the next column? I am displaying student class ID and class ID. Okay. Actually, it's not, doesn't make any sense, but just for the practice purpose. Okay. What is the CID in both? Obviously, 101, 101. Otherwise, it wouldn't even fetch. And what is the class name for 101? 101 is Java, right? So that's the first record. Okay, so next student, what is the next matching one? 100 is matching, right? 100. Okay, don't worry about the lines. These are confusing. These are moving back and forth. So I'll remove. Okay, so 100. 100 is to be 100, right? To be class ID is 100 and student class ID is 100 and class ID class ID is 100. And what is the class name for 100? Testing. Simple. Okay, so what is the other CID that is matching apart from 101, 100? Yes. 3 also matching, right? 3C 101. 3C 101 and class ID is 101 and class ID testing 101. Sorry, it's Java. Okay. So only this mentions how many students are, what are the different students, what is his ID and what is his name, what are they enrolled in, what is his class ID. Okay. And so only difference is here we are just pulling those records which have the class ID in both student table and class table. Okay, anything else? No. 102 is there, right? 102. 4D 102 automation. 4D 102. Again 102. Automation. Anything else? 102 is there. Null is not common. 103 is not common. One null is there in the student table, not in the class one table, so it won't come in output. And 103 is in the class one table, but not in the student table, so obviously it won't come in the inner join. So that's it, that's the output. So both have matching columns where both CAD are matching in both tables, so only fetch those records. Simple. Inner join is very simple. Okay, we will try this and then outer join. Okay, what are the outer joins? What is this? What are the outer joins used for? So inner join is used for fetching the matched data, right? So outer join is to get unmatched data from tables whose data has to be displayed depending upon type of an outer join. So while displaying the output, this unmatched data can be displayed alone or along with the matched data. So that depends on what type of outer join you are specifying. So first type of outer join is left outer join. So like the name suggests, left outer join returns the unmatched data from the left table. Okay, so the corresponding values from the right for the right table will be null. So this returns unmatched data from left table and corresponding values for right table will be null. Okay, so we will use the same tables and try to apply the output. Okay, so I'll give you example and you have to write the SQL query. Instead of me writing SQL query, you will write SQL query. So I want to get the details of all students along with classes. Okay, so now how do you write the left outer query, left outer join query? So solution is, our SQL query is select SID, yes name, and yes.cad, which is student class ID, c.cad, c name from till here. I want to get the same columns as in a join from student. Yes, now you have to mention how it is joined with the right table. Left outer join is the keyword. Class C, on condition s.cad equals c.cad. Okay, now what output it will display? Now if you tell me right now you have understood theoretically, then we can always apply on the we can write this query and execute it on the whatever database software you have. Okay, so tell me what is the output it is going to retrieve. So it returns unmatched data from the left table, but corresponding values from the right table will be null. Yes. So you look at this, what is the opposite of this? 1, 2, 3, 4, right? So what is left over here? 4, 5, isn't it? Or 5. Okay, 4, 5 also. 4 is also there, isn't it? Yeah, 5. 5 is definitely. 102, is it a part of 102? Is yes. 103, yeah, 103. Okay, but we are talking about the left outer table, left outer join. So from the left table, yes, from the left table, all records will be there, but non-matching records will be null, and this is same. So the output look like this. I'll take the same output. So 1, 2, 3, 4, right, returns unmatched data from the left table and corresponding data. So same as this, and 4 and 5th. Okay, 5th is A, B, C, D, E, and the student ID, these will be null. Right, that's all. Anybody understood or not understood? We will see more of. If you don't understand, don't worry. Now let's take another example on this category. Get the student details who are not assigned to any course. Okay, so now tell me the output manually, and we will write a SQL query and then write the output. Okay, so student, who are the students who have not been assigned any course? Yes, in the student table, look at this and tell me who are not been assigned any course. Class, that means do not have any class ID. Student number 5 does not have any class ID, right? The student E does not have any class ID. That means he is not assigned any course. So you have to translate this into SQL, from English to SQL. Okay, so the output obviously we'll write the output first and then write the query. Okay, output will have student ID, student name. Who is not assigned any course is number 5 guy, and whose name is G. Okay, that's output. Now how do you write SQL? Select SID, SName. I want to only retrieve the student ID and student name who does not have any course associated with him, or he is not enrolled in any course. Okay, the syntax will remain the same. From student S, left outer join class C on S.cid equals C.cid. Now this will retrieve all the data we have already seen. So until this portion, it retrieves all the data, that unmatched data from the left table, and remaining with the null values, right? Now we just have to put a condition who are not assigned any of the courses. So where, tell me what is the condition? How do you translate this not assigned any course? Course is null, right? So what course is null? C.cid is null, right? That's it. This will retrieve this output. Okay, so right outer join. What is the right outer join? It returns all unmatched data from right table. Instead of left table, right table. And corresponding values from left table will be what? Yeah, will be nulls. So you just take the opposite of left table in terms of output, and that will be your out, this one. Okay, so same query. Get the details of students along with the classes using this. Okay, so let's take the output also and we will modify it and how it would look like. Okay, so get the details of all students along with the classes using outer join, right? That's my English query. Now my SQL query is simply, instead of left, I will use outer join. Oh, sorry, right. Okay, so simply it will be the other way around, isn't it? So here, yeah, student ID 1, so this will be null. Null, or you can just put this. Okay, for 2 also same thing, right? Okay, let me put this. Class ID same as above. Okay, 3, 4 also same thing. So it will be exactly opposite. boom, and boom. Okay, same thing for this guy. Okay, and for 5 it will be null. Sorry, 103. Class ID will be 103. And class name will be, for 103 guy, what is the class name? Database. Okay, so this will be the output of right outer join. So let's take another example and apply the right outer join for this one. Okay, now you tell me the output. Okay, so get the details of students who are not having any, get the details of classes now this time. Who are not having any students. Okay. So instead of left outer join, you use right outer join. Okay, so the output is which course do not have any students. Obviously the 103 course, right? 103 database, no student is enrolled. So student ID will be, class ID. So in this case, I want to retrieve class ID and class name. Okay, so class ID will be 103 and class name will be database. Okay, so you just have to practice more in order to get wrap your head around it. Full outer join is a combination of both left outer join and right outer join. So this will return all the unmatched data. From both left and right table. Okay, so same examples and only the output changes. So I'll just take the same example. Get the student details and class details, and SQL query will change in terms of the keyword that we use. So here, okay, actually I will take this example. So instead of left or right, you mention what is the keyword? Full outer join. Same condition, it doesn't change anything, only the output does. Okay, so output would look like, so just definition tells everything, returns all the unmatched data from both left and right. Okay, so here everything is same, and only here null null null. And fifth is E, right? 104, 103. Okay, don't worry about the output, it may not be accurate, just concentrate on the SQL. When we actually run this on the SQL developer, we will know. Okay, so that's about outer join and inner join. Then comes cross join. We'll discuss and then we'll jump to the practical. Cross join it's a Cartesian product basically. So common columns, and it's both taking product of, all permutations and combinations. So that's a cross join. The output will be the product of number of records between the tables. So this cross table is mainly used to get combination of data between the tables, to get combinations of the tables. Okay, so we'll directly jump to the example. Now my example will be get the possibilities about assigning of classes to students with more than 200 marks. Okay, that's my query. Now how do you write SQL query for this one? Select SID, student name, c.cad, same as before. I'm not changing anything. CNAME from students. S, cross join is a keyword. Class C, where marks is greater than 200. Okay, so that would retrieve the output. So don't worry, I'm not going to write the output here. We are going to see it directly. Then self join, as the name suggests. What is the self join? It's joining a table with itself. Table to itself, and the same table is used twice to distinguish between two copies of the table. We can use table aliases just to differentiate between what table is a copy and what table is original. So in the syntax of the self join, we never use the keyword self, unlike we used the keywords as in the join type itself. So this is internally, it will perform inner join automatically, but just by mentioning the table name twice, that would indicate the copy. It's a replica of the same thing. It would automatically apply the inner join, but it will know automatically that it's a join applied on the same table. So query will be get the details on employee table along with their managers names from EMP table. So in this table, one of the employees will become the manager for another employee. So because the manager in the first place is an employee, so the employee who are the managers are the will be employees will become managers for the other employees. That's a basic funda. Okay, so I don't know how to get this table structure on the notepad. Okay, so let's say already you have this table, right? EMP table. So EMP table will have EMP ID, EMP name, and manager ID, right? You have this. And I'm going to make a replica. So this replica will be called, let's say, EMP A, EMP B. Okay, so both replicas of each other. So hence I'll be putting automatic inner join will automatically implicitly apply the inner join between the same table copies. Okay, so here the SQL query look like select a EMPA comma EMP ID comma EMPA dot ename EMPA dot manager ID, then EMPB dot ename. So EMP dot B name, EMPB dot ename. So I'm going to call this manager from EMPA inner join is a keyword again, then emp b. Okay, so don't get confused. Emp is a table and alias name for the first copy is empa, and I'm joining the same table on same table with the same table emp whose alias is empb. So this will fetch all the employee details along with their manager IDs and manager names. So would look like this: emp ID, emp name, manager ID, and manager name. So for example, 100, emp name is Shukla, manager ID is 105, let's say, and manager name whose manager ID is like it's the employee name of the 105 guy. Employee ID is, let's say, Russell. Okay, so that's his manager name, and we have so you can also join multiple tables with a complex inner join. So that would look like select column list from table 1 inner join table 2. So far we have seen 2 tables only, right? And on mention on criteria. Now you can put inner join with third table also. Inner join table 3 on criteria. So you can mention as many inner join on as many tables as you want from inner join. Let's cut here. Okay, so this list you can continue with any number of tables. So okay, so let's see these inner joins before jumping to subqueries. Shukla, I think, right? Shukla, can you connect your machine?
Okay.
So let me make you the presenter. Yeah, okay, now you're the presenter. So go ahead and share your screen. Okay, let's start from where we have started. I mean, you can practice the constraints.
You share the okay?
Yes, yeah, you can.
Okay.
We'll directly start joins so that. Okay. All right. So you have EMP table already, right? So let's see.
Yeah. You have I have a class table also. Today I put the data already inside. Class and student.
Oh, okay. Class and student tables. Okay,
Yeah,
perfect.
yeah.
Let's
Just check it. Just select command and check it.
So class table, class one table.
Yeah, this is the data.
Class one table is CID, CNAME, CZ. Perfect. So
Student table.
Select start from student. Student table has student ID, student name, student. What is this? Can you read this? It's not very clear.
Or you change something for ID number?
Okay, now it's clear. Student number, right? Student number, let's make it CID has to be common column. Join. So let's see again. Class has CID. Okay, so that's our common column, and student has to have CID as well. Yeah, so we have to make this S number as CID. So that way we have, I mean, doesn't matter class size, age is fine, but yeah. Okay, how do we change the column name? Or you can insert one more column, right? Student number can be there. So let's insert. Okay, Shukla, can you insert another column? So what is the command? Alter, add, right? Insert it into the student table. So that way we have common column.
CID, huh?
CID, right? CID data type is
Integer.
here, right? Okay, and a student is having typos.
Okay.
Okay, run it. And,
STUDNT student integer.
we can drop S number table also, or can
Okay.
you
First time
change
create it
S
or
number
drop it
to student
first?
number? Yeah, can you just change it S number to student number? A student
Modify. Modify. I will use the modify.
modify. Yeah, modify the column, and that would be easier, right?
Modify. DIF. Modify. SID.
S number to CID. S number CID. S number to CID.
SID to CID.
S number. S number is the existing column name, right? Then we want CID column.
No, I'll change the S and O. This one I'll change it only for this student ID is automatically this one is not working. Student ID. We are working only for S and O and then.
Okay, run it and see.
No, this command is not a fulfill. Alter table student and then modify SID and I will.
Run it and see. It's going to throw error.
Okay, maybe error is occurred.
That's not correct. So okay, let's go with the first approach only. Let's add. All we want to do is the joins, right? Let's not worry about extra columns.
Yeah, syntax error, sir. Yeah.
Right. Yeah, that's what I thought. So just add one more column called CAD.
Yeah.
Then we will start inserting 5 records. That's fine.
Yeah, this one is added.
Okay, now run the select query again to see.
Yeah.
Student ID, all null, right? So, okay, now insert one by one CID, same thing, 101, 102, 103, 104, 105.
Okay.
But we will have an extra to not to match something. So that the outer joins.
Okay, I will be joining to right now.
No. You had to enter the CID.
Okay, wait. That's what I'm thinking. I have a student table is there and manual I'll do it. Where is the student ID? Table.
No, you can do it from the query, right? Don't go. So all you have to do is update table.
Okay,
Student.
okay, update.
Set CID equals to 101, where S name is equal to Shukla, and run it from Python.
Student.
Yes, set
CID 11, huh?
101, yeah. Where serial number is 101, that would be easier, yeah. Where S number is 101, that's it. Then we will just change the values.
Number
Equals 101. Okay, there is a typo. CID equals 101. Equals. Now run it.
Yeah, one row.
Okay, one row updated. Okay, so likewise we will update all the 5 rows.
Because we need the commit, otherwise data is not saved.
Yeah. Okay, now
I'll copy paste 1, 2, 3, 4 like that.
yes, yeah, 102. Don't
Yeah,
copy, just change it right there. Huh?
No, just right there,
102.
just a field is changes.
Okay, it's up to you.
Yeah. Pachi, come please.
Okay. Then run.
I'm
Just want
fine.
to pop data populate.
Yeah, I'm talking.
Then what about lunch? Okay.
Mukta, she cook something and then I did, okay?
No, she cook.
Yeah.
Rice.
Okay, thank you.
Okay. What you are doing?
Just I'm doing something.
Okay. Come out when you.
Yeah, after. Oh my goodness.
Okay, so now run the select query. Okay,
Yes.
perfect. So, okay, let me take control.
Yeah.
Did you commit it already?
Yeah, committed. Yeah.
Oh, good. Okay, so let's run student. I want to have one student who is not assigned any course, just to get the different results for the right outer join and full outer join, right? So, oh, you already put CID. Okay, let me
Okay, you
change.
put the number 6, that doesn't matter. I did.
No, not number 6. Let me take control.
Yeah.
So I want to set CID equals to null, where CID is 105. Okay, so that's perfect. Okay, let's also see select start from class 1. Class 1 have CID, CNAME, C size. Okay, so 106 is perfect, 101. So I just want to have common and uncommon, unmatched, matched and unmatched. Okay. Okay, so now let's apply the joins. So first is, what is the first join we talked about? Inner join, right? Inner join on tables. What is the left table? This table we are treating as left table, student table. Is left table and class 1 is right table, so that we have clarity. Okay, now I want to join both tables based on a condition. I want to retrieve the data from both, right? So my query would be select star from, or instead of, okay, let's put star first and then students, oh sorry, student yes class 1 C where condition is must for inner join. Okay, so s dot cid equals c dot cid. Okay, now let's run. Probably right. Okay, so now what are the common column? What are the CAD? CAD and CAD underscore 1 is coming, right? So that is the ambiguity, since because I did not mention which CAD belongs to which table. This belongs to student table and this belongs to class 1 table, but it's not very explicit. Let's use it. So the inner join uses only those columns which satisfy this condition. So what are left out here? 105 is left out because it doesn't have 105, okay, doesn't have CAD, right? So it is not part of inner join. Understood? Did you understand this or any doubts? Okay, let's put more explicit so that you will understand. So I want to retrieve student ID. So this is my query. Get the details of students along with their class names from both student table and class table. Okay, simple as that. Now I will retrieve student ID, student name, and s dot cid, okay, which I want to call as student class ID, right? And then c dot cid, this is the class ID, class ID, then class name from student as class C. Okay, so okay, nobody is mentioning, I did not use the word inner join, right? So student as inner join class 1 C where okay, where is not a keyword. Initial, okay, the before example is not for inner join. So why? Because I didn't use the inner join itself. So on is a keyword where that simply use the where condition. Okay, now this is a example for in. Okay, SID is, where is SID?
Need space, student and then class, you write them together.
No, student has SID. Student ID. So we have to use student ID. Not space, not is the issue. The column name was wrong, right? Okay, so same result, but okay, what do you see the difference? The both tables have common column called class ID, and only the common columns row data is fetched here. So the columns are 102, 101, 102, 103, 104. Okay. Now let's check the student table here quickly without running the query. Okay. So okay, I wanted to pin it. Okay, it will not go, right?
No,
Right.
go. Which one you do it? Just click it.
No, that's okay. So yeah, here if you see 101, 101, 102, 103, 104, right? Now let's open the class table also. Yeah, that's what I'm saying. If I open one table, other table will be gone. I wanted to pin it. Where is the pin? Do we have the pin? There's no pin symbol. Okay. So anyway, 101, 102, 103, 104 are there. What is the uncommon columns which are not common? 105, 106, which are not displayed. Right? 101, 102, 103, 104. Only the condition, the rows which satisfy the condition are displayed. Simple. Okay. Any doubts? I'll move to outer join. So first outer join is left outer join. Right. Okay. So the only difference is I had to use the keyword left outer join. That's it. So
Only
that
for left or right is the
everything
same.
will act according to the definition.
S is missing. Just select S.
Okay. Student. I thought I copied it. Okay, so instead of inner join, you have to mention left outer join, right? Okay, now you think of what would be the output and just compare it with the actual output.
To write down the full outer OUTER, otherwise this one is red.
Yeah. Why it is seeing this?
Yeah, this one is okay.
Okay, controllers. What is the shortcut? Control enter will also enter. So let's try the shortcut. Control enter. Okay. Okay. Now explain. Can you explain, anyone, what it is, what it did, and how did the left outer join work according to definition? Anyone? I already explained. You just
Yeah, unmatched data also coming.
unmatched data from where? Which table? Left table or off table?
Left table is not unmatched data is coming, but outer left outer join unmatched data is coming. All of them, match or unmatched, all of them is coming.
Not all of them. Not full. This is not full outer join. Left outer join
Yeah,
only.
left side is joining left side. They match the data. That all of them left side only for left outer side.
Right. Left outer join fetches unmatched data from the left table. Just remember that.
Yes. Yeah,
And
left.
for the right table, the corresponding values will be null. So
Yeah.
this is a left table and corresponding values for the right table is null. Okay, so similarly, right outer join, it will be the exact opposite of left outer join.
Yeah, right
I mean,
side is matching
not
and that
the
right.
opposite, it's the other complement. So if you both combine left and right, that will be a combination of which is called full outer join. So let's just run right outer join. Okay, so it's unmatched data is coming from right table.
Right table.
Okay, that is now if I run the full outer join, it will be combination of both left and right outer join. So you just need to practice yourself to in order to understand it fully. Okay, so all are coming. This will have all the data from both left and right and corresponding values for the left, corresponding values for the which will be null, both left and right. All the unmatched data, basically the unmatched data from both left table and right table will be displayed no matter what. So cross join, is nothing but, what is a cross join? Join without a common column criteria is called cross join. So the output will be product of all the records. So you simply select, I can put star from student, yes, class 1C. Okay, so that is a all combination Cartesian product. So if you see one Shukla, one blah 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 C size, then one Shukla is repeated for all the rest of this. Okay, and then two Russell and three Nixon. So it's like if first table has how many columns? Let's see. Class table has 1 to 3 columns, and student table has how many columns? 1 2 3 4 5. So the cross join table will have 5 multiplied by 3, 15 columns. Okay. So and rows 5 into 6, 30. So total records will be 30 in the Cartesian product, and the columns will be all combination basically. Okay, so the rows will be, if first table has m number of rows and second table has n number of rows, the cross join of both tables will have m multiplied by n number of rows. So basically it's a all combinations. So one put together all other, and true fix one, and just repeat all other for fix one. So that's what I did here. So cross join is not good way of joining because it has lot of redundant values, duplicate. So it's not very used unless you want the all the data, all combinations and stuff. So next, self join. So what is a self join? We will join the same table with itself. So which table you want to take? Employee table. Let's see. Select star from empty. Okay. So the query will be like this. I already told you the query, right? So get the details of employees along with their manager names. So here, if you look at it, employee number has employee name, okay, but manager number does not have manager name. But a manager is also an employee in the first place. So manager has employee ID, hence manager will have the manager name also. So my query is get the details of all the employees along with their manager's number as well as manager name. Okay, so simple. So that is only possible by joining this table with itself. Okay, we'll end this session in like
ক্লাসে আছে পরিমাণ দিচ্ছি
employees
কি লাগে
with their manager names. Okay. Okay, so SQL query, select. So let's call replica of this is A and B. Okay, both are the replicas. So I'm going to join both of them. A dot emp id or emp number, A dot ename, A dot manager, all right, and B dot emp number or emp name. So we want emp name or ename, okay, which I'm calling as manager underscore name from empa inner join. So like I said, self join is nothing but inner join, but applied on the same table, and it's copy. emp on condition is, what is a common column here? A dot manager equals B dot manager, B dot emp id or emp number. Okay, so that's a column, so do not get confused. Manager id is nothing but employee id. The only difference is he is a manager. Okay, let's try and run this. Okay, so emp number and emp name and manager for this emp 4Ds, employee 4Ds, his name is Jones. So that's what we want to fetch. In the original table, the manager name is not displayed. Okay, now let's check manually if it is correct or not. Okay, so Ford has manager Jones. Okay, let's see employee table. Okay, Ford. Okay, tell me, how do you manually verify this? Where is Ford? Ford
is number 13.
Ford is number 13, 7902. What is his manager? 7566. What is 7566? Jones. Okay, so here it is. So Ford's manager name is Jones. So all I displayed is his manager's names in the same table. So that's done. Okay, now let's take one more. Everybody understood this, right? Get the details of that is only possible by joining the table with itself by putting on condition on manager number with the employee number, because manager number is in other terms it's an employee number who has an employee name, and in turns that is called a manager name simply. Okay, let's take one more examples and see. Okay, Smith's manager. Okay, again Smith. Okay, Martin's manager name is Blake, right? Now Martin. Okay, Martin manager number is 7698, and 7698 belongs to Blake. Okay, whose job is manager, of course. So here Martin is a salesman. Okay, who has a manager whose number is 7698. So I'm looking for the employee whose employee number is 7698, and what is his name? Blake, and his role is manager. So Blake is the manager of Martin. So in order to just put it in a single table, you have to write the whole self join. Okay, now that's about the joins. Tomorrow we will see more on subqueries, inner queries, and stuff like that. Okay, and practice more nested subqueries, simple subquery, and inner queries. Okay, so you can try this inner joins with more tables. I guess Shukla, you have created more tables, persons, but this is empty. So
Yeah, no more data.
just insert some data and
Yeah,
play
okay.
with it. And
They'll create the data.
right, yeah.
Yeah.
And everyone is practicing, right? I mean, I'm only looking at because I'm taking Shukla's machine for practical. I don't know how everyone is doing, but everyone do. And tomorrow we will complete the database, and hopefully we'll start the web services testing with the SoapUI and Postman. At least we'll start SoapUI if time permits, if we are able to, because tomorrow is just 1.5 hours class, right? And Russell is going to take over after 1.5 hours for the lab session. Hopefully you will practice more on the database SQL queries in tomorrow's lab session. So we will just finish the database tomorrow and start this web services testing part on next class. Okay, so that's about it. It's already 1:19 for you. Okay, guys, so we'll meet in the next class. Bye-bye.
Bye.
Okay, I'll just save this. Don't worry, I have copied the queries, so I'll share the notes with you. Okay, all right.